Hey everyone, and welcome to this explainer. Today we're diving into something really cool. We're looking at a brilliantly simple, totally sustainable, and honestly surprisingly effective seed germination experiment. It was documented by this super passionate home gardener named Ang. Now, if you've ever, stared at a pot of dirt for 3 weeks, literally praying for a stubborn seed to sprout, or if you're just someone who loves practical, real-world science that you can do right on your kitchen counter, you are absolutely going to love what we're unpacking today. We're talking about a method that completely rethinks the basics of propagation. It uses everyday items to create this perfect little microclimate for new life.
Okay, let's dive into this by looking at the exact challenge that kicked this whole experiment off. So Ang recently went out foraging, right? And they harvested some wild peacock flower seeds, specifically this absolutely stunning reddish-orangish variety of a plant that is scientifically known as caesalpinia-pulcherrima. Now, foraging for wild seeds is an incredibly rewarding experience, but man, it presents a massive hurdle. I mean, how do you reliably wake these super tough, completely dormant wild seeds up once you actually get them home in your kitchen? Nature specifically designed these seeds to survive really harsh conditions, so they've got this formidable, rock-hard outer shell. So, what is the absolute best way to coax them into germinating without, just rotting them in the process? Well, Ang decided not to just guess, but to set up a real, controlled test.
Which brings us right to the germination experiment itself, pitting the old method against the new. To find the answer, Ang basically set up a head-to-head botanical battle. So on one side, we have the classic, widely used baseline. You know the one, the regular paper towel method. This is literally what almost all of us learned back in grade school science class. You wrap the seeds in a damp paper towel, slide them into a plastic Ziploc baggie, and just kind of hope for the best. And hey, it works, but it's notorious for being wildly inconsistent. On the other side, Ang introduced this newer experimental water-soaking technique, and right out of the gate, the notes from the experiment point out that this water-soaking approach showed highly promising results. It was clearly outpacing the traditional method in both speed and just overall success rate.
Now, what's really interesting about this next part is the mechanics breakdown. Let's look at how this highly successful water-soaking method actually works in practice.
The true beauty of Ang's discovery is really in its absolute simplicity. It's just a super straightforward 3-step physical setup that literally anyone can replicate. Okay, step 1, you take a long, tall glass jar and you add just the bare minimum amount of water needed to keep the seeds moist. We are definitely not drowning them here. We're basically just providing a very shallow little pool of hydration right at the base. Step 2, you use a plastic cup, turn it upside down, and use it as a sort of makeshift dome or cover over the jar. This is going to trap all that crucial moisture inside the vessel, creating this perfect miniature greenhouse effect. And then step 3, and this is absolutely vital, you have to ensure that the plastic cup has an opening for aeration. You do not want to seal this thing off entirely.
That specific setup brings us right into this crucial balance. It's all about moisture versus aeration.
So the crucial point here is understanding exactly why those 3 steps we just talked about matter so much scientifically. The environment inside that tall glass jar creates this, perfect balancing act. First off, Ang's notes highlight that this method is absolutely ideal for large seeds, kind of like the peacock flower seeds being tested here. See, large seeds need to undergo this process called imbibition, which is basically just the initial rapid uptake of water that softens up that hard outer seed coat and tells the embryo inside, hey, time to wake up. The plastic cup traps the necessary moisture so that softening can actually happen. But, and here's the kicker, because of that intentional opening we mentioned earlier, the aeration prevents mold from forming. Stagnant, humid air is just a breeding ground for fungal spores, and mold is without a doubt the #1 killer in seed propagation. Getting the airflow right is notoriously tricky, but by striking this perfect balance, the environment actively encourages strong, healthy root formation without rotting the seed before it even really gets a chance to start.
The results of this balancing act were so incredibly effective that Ang actually documented this big takeaway. Quote, "The tall glass jar is quickly becoming my favorite medium for any form of propagation, whether for cuttings or seeds." End quote. I mean, wow! That brilliantly illustrates just how much a simple, well-thought-out experiment can completely revolutionize a gardener's standard operating procedure. This wasn't just, a mild success or a neat little party trick. It genuinely became the new gold standard for all of their home propagation moving forward.
But wait, there is a wonderfully charming, eco-friendly twist to this whole story. Let's look at the upcycling bonus, where we see the repurposing of some pretty unexpected household items.
50, yes, 50. That is the completely unexpected number of long dormant glass jars that Ang just happened to have lying around the house. Honestly, Ang didn't go out and buy any fancy, expensive, specialized botanical glass domes for this experiment. No way. It turns out they had well over 50 glass jars that used to hold betta fish, which, well, honestly, it kind of begs the question, just how many betta fish did Ang actually own? But actually, scratch that. Regardless of the fish count, this brilliantly effective scientific setup was built entirely by repurposing old betta fish jars and random plastic cups. It is just a massive win for sustainability, and it's definitive proof that you really don't need expensive high-tech gear to innovate right in your own home.
So where do we go from here? Let's see how this builds into our final section. What comes next as the experiment expands?
As you might guess, Ang isn't just stopping with the wild peacock flower. The immediate next step is to take this proven upcycled glass jar method and test it against commercial seeds. Ang recently went on a little field trip down to a few local plant centers and nurseries and picked up a wide variety of other plant species. So the big goal now is to see if this perfectly balanced microclimate of moisture and aeration works just as miraculously on commercially processed seeds as it did on the tough wild ones. Commercial seeds, they can sometimes just sit in those little paper packets for months or even years, which puts them into a really deep state of dormancy. So testing this rapid hydration technique on them could yield some absolutely fascinating comparative data.
Which brings us to a final, really exciting thought. Which plant species is this upcycled glass jar method going to revolutionize next? The core principles we've covered here, using the bare minimum water, trapping that moisture, and ensuring targeted aeration, they are completely universal in the world of botany. The fact that you can perfectly achieve this delicate microclimate with an old fish jar and a plastic cup, that is incredibly inspiring. It invites all of us to just look around our homes, grab an empty jar, and start our very own scientific experiments. So, what seeds are you going to try to wake up using this method? Thanks so much for joining me on this explainer, and hey, happy planting!